Welcome back to the geology classroom. This is a continuation of the ending of the last video I made. Just continuing the topic of geology. More specifically, mineralogy, which is the study of minerals. Before I get too quickly down the path here, the rocky path, I want to talk about the difference between a rock and a mineral, because there is a difference. So basically, a mineral is an atomic structure. It doesn't have to be natural. All the ones you see here are natural, but now with lab-made minerals, they don't have to be natural, but they are atomic structures with distinct crystal structures and chemical formulas. Also distinct physical properties, but we'll get into that later. Thing is, minerals don't have to be made up of multiple elements. All of these are, but there are some minerals that are single elements, like gold, for example, is a mineral, but it's just gold, right? It's on the periodic table. It's Au. Also, diamonds are just pure carbon. They are a mineral, but they're one element. Anyways, so yeah, that is a mineral, an atomic structure with a very specific crystal structure and a specific chemical composition or chemical formula to it. Now, a rock is an amalgamation of multiple minerals. So these are single minerals. A rock is combining this mineral with this mineral, maybe this mineral, this, and putting it all in one to get something like this. This is a rock. What you're looking at is a piece of, high feldspar granite with like a K-spar, potassium feldspar, which is, these, maybe some plagioclase in there with like some amphiboles, also some quartz, which is this. So it's an amalgamation of multiple minerals in one. This is also a kind of granite, and this as well. Multiple minerals in one. Whereas this is just a single mineral. This is just feldspar. So there we go. The difference between a rock and a mineral. So now, getting into mineralogy, which is the study of minerals. By the way, the study of rocks would be petrology. Getting into mineralogy, we're going to cover the most basic topic, being mineral properties. All right, so if you were to take a mineralogy class, the first topic you would probably get into is certain mineral properties. All minerals have distinct physical properties and sometimes, chemistry-like properties that they should exhibit. And there's a pretty long list. Some characteristics of minerals or properties of minerals are rare, and others are extremely common. So we'll get into the properties of minerals and cover some good terminology. The first one we'll cover is very simple. Basically, mineral properties are, you could think of them as mineral characteristics. And when you're identifying minerals as a mineralogist would, there's certain questions you want to ask yourself. The most basic is, what color is it? So minerals can come in all kinds of colors. And it's the easiest question to ask yourself when looking at a mineral. What color is it? This mineral is purple. This mineral is kind of orange, a little clear. This mineral is colorless. This is also purple. These are kind of green. They have a green tint to them. Kind of pink or red, light pink. Color. Very easy mineral property. Just ease into this with some very beginner stuff. The next property is luster. Luster is the visual appearance of a mineral when light reflects on its surfaces. So, luster, you would use certain words to describe a luster, like shiny, maybe even glassy. This is very glass-like. It's very reflective. These are all descriptions of a luster. Shiny, metallic, dull, waxy. Even a type of unique luster, I suppose, would be iridescence. This is a mineral called Labradorite, which is iridescent. Other examples of iridescent minerals would be opal, has an iridescent luster. Opal diffracts light, so you get a color play. Anyways, luster. The third mineral characteristic would be a color streak. A color streak, this is something that mineralogists will do, and this is something you would most definitely learn in a class, is you would get these small porcelain squares, and you would take a mineral and scratch against the porcelain square and see what kind of streak, if it leaves one, what color it is. You know, some minerals may be a certain color, but the streak they leave behind could be completely different. I don't have a porcelain plate with me, but I can show you examples of a streak. This is a piece of graphite found locally. You can see that if I even just run it on the paper here, it leaves black streak. It's also very brittle, another characteristic of graphite. So color streak. Next, hardness. Hardness can be, we go over that in a different video, but it is a mineral property, a pretty important one, because all minerals have a certain hardness, and this is why this iron nail is sitting here. This is a tool that probably most geologists carry, and most petrologists or mineralogists carry, especially in the field. Basically, the hardness of a mineral is determined on the Mohs scale, which is a specialized scale that basically sees how resistant a mineral is to being scratched, how easily the mineral can be scratched. And the hardness ranges from 1 to 10 on the scale, 10 being the hardest, which would be diamond, and 1 being very soft, like talc. Talc is a very soft mineral. It's used in baby powder. So the Mohs scale is what you'd measure hardness with. Basically, the important thing to take away is how easily does the mineral get scratched. If this iron nail is not able to scratch the mineral, then it means it's at about a 7 on the Mohs scale. Next mineral property is a pretty important one, fracture. It's probably one of the top ones a mineralogist or petrologist would test in the field, is to fracture the mineral and to see what kind of fracture it yields. There are a few different kinds of fracture. The most commonly known is conchoidal. But sometimes when you break mica, you can get like a fibrous fracture. It doesn't fracture very cleanly, it splinters. You can get a very brittle fracture where it just crumbles or turns to powder. And then you get a very common one like this, which is a conchoidal fracture, which is where it breaks in a circular pattern, like glass would. All right, next mineral property would be density, I suppose. Fairly important. Each mineral has a certain density. Basically, the density, this would be pretty complicated to figure out at home. But basically, you'd have to figure out the mass of your mineral, also the volume of your mineral, and density is mass divided by volume. And once you get that density, you can go look it up and make sure the mineral matches with what mineral you're looking for. It would be complicated to do this at home. Next mineral property is tenacity. Tenacity is basically how a mineral recovers from stress. A good example of tenacity that I can show you is mica. This is a very thin sheet of it. And when I go ahead and bend this, see I'm bending it, it just goes right back. So this is a elastic tenacity. It just wants to bend and snap back. Whereas some of these minerals, if I were to try and bend them, they'd get past a certain stress point and they'd just snap. This one, if I continue to bend it, it will eventually snap, but it won't break evenly or very cleanly, right? It's very fibrous. All right, I'm going to take just a quick breather from all that, let you process all the mineral properties I've just gone over. And, I like to have things written down for like visual learners. And I like to have the rocks displayed out and show you each characteristic. But it's getting to be a bit much packed into such a small amount of time and a lot to learn or a lot to process. So I'm just going to slow down right now and just showcase some of these minerals that I have and that I've personally collected locally. So the first mineral I'll show you is quartz. This is a piece of a quartz vein. Silicon dioxide is quartz. Quartz is a tectosilicate, and it's very common. It's a very pretty rock. It has nice lusters. It's vitreous, kind of glassy, a little bit waxy here and dull. It's non-metallic, sometimes transparent. It's very tough, very hard and durable. Another mineral, feldspar. Who doesn't want to look at this, right? Focus, you bitch. There we go. Labradorite. A type of iridescent feldspar. Exhibits blue hue color play. That's hard to say. Biotite mica. Gets that dark color from the high aluminum content and potassium, iron. A lot of metals in this mica, which makes it look metallic almost. These over here, some of my favorite minerals. These are cyclosilicates in the silicate grouping of minerals. They are black tourmaline, also called scoral. Goes by many names. It's got contents of silica, aluminum, iron. But the most notable mineral would be boron. Very jet black. It's got a shiny, dull luster. Triangular kind of shape. The color is black. It's got a decent density to it. We're slowing this video right down. Check out some garnets found at a local mine. These are neosilicate minerals in the silicate grouping. These garnets are spessartine garnets. Very pretty. Rough shape though, these aren't gem quality. These are very rough shape garnets. Check out some mica sheets. This mica, this muscovite mica, exhibits a kind of green color. It's super reflective. Here's a geode. A piece of pyrite. Alright. I think we'll get back into the mineral properties now, after we've looked at some of these. We went over streak, we went over hardness. Next, we'll jump into cleavage. Certain minerals exhibit cleavage. Cleavage is when a mineral exhibits breaking on parallel patterns, angular faces. This mineral, when it breaks along very flat planes, very sharp angles. And essentially, those points are weak points within the crystal structure, the crystal lattice structure, where it just naturally is weak and wants to break. The crystal can't hold up. So all of these minerals exhibit cleavage. Some are uneven cleavage, some are perfect cleavage, some are 180 to 90 degree cleavage. Depends on the mineral you're working with. Some minerals don't exhibit cleavage at all, like the obsidian rather exhibits a fracture than cleavage. Cleavage is reserved specifically for the angular fractures of a rock. All right. Next, acidic reaction. Some minerals react to acid. This would be also one of the very first tests that a mineralogist or petrologist would do out in the field. So, examples of certain minerals that react with acid, many carbonate minerals. I'll show you one right here. This is a piece of limestone conglomerate. And as I drop, I want to get this in focus. As I drop a bit of acid on it, see that bubbling right there? I can even hear it fizzing. It is reacting with the acid. So that indicates that there's carbon in the rock. All right. Other mineral properties. A mineral property, probably a very important one, would be crystal formations or crystal structures. Each of these minerals exhibits a very specific crystal structure. Now, this is not important to you if you don't have specialized microscopes. That is the only way you will see a mineral's crystal structure. But once you see that crystal structure and you are familiar with crystal structures, it is a very, very clear way of identifying what mineral you have. Also, XRF machines are good at doing that. All right, another mineral property. These are a little more rare. The first one being conductivity. Conductivity is basically the mineral's ability to easily allow heat or electricity to pass through it. So I have a piece of galena. It's actually not on this table. But I have a small piece of galena. Galena is a conductive mineral. Also gold, copper is conductive. Those would be examples of conductive minerals. They can easily allow electricity or heat to pass through them. Now the opposite of that kind of the opposite would be a refractory mineral. Also another mineral property is refractory. It is the ability of a mineral to resist heat and retain its durability at high temperatures, or its strength at high temperatures. First one coming to mind would be quartz. Quartz is extremely durable at high temperatures, considering what it's made of. Silicon. Silicon, in its pure elemental form, silicon metal, which is extremely rare in nature, is extremely resistant to heat and high temperatures. And it holds its durability and strength at very high temperatures. You know, you can hit that stuff with a blowtorch or set it in a furnace or a fire for a good while, and then let it cool down for like 2 seconds and pick it up, and it'll be perfectly fine. You know, it's very resistant to heat. All right, a very common one. I can't believe I didn't mention already. I should have mentioned this at the beginning, but is taste. Some minerals, now I'm not saying you should put all minerals in your mouth, that's a very terrible idea, but some minerals exhibit a very unique taste. The first one coming to mind would be halite, which is salt. It's basically the mineral salt. And if you were to take the mineral, if you weren't sure what it was, if it was calcite or fluorite, a good way to check that would be to just touch it against your tongue. And if it tastes salty, then it's most likely halite. So taste. Just don't taste every mineral. Generally, it's safe. Like if you were to put feldspar or quartz in your mouth, it's whatever, right? But they won't really exude a certain taste. Now, I just dropped my notes. I guess I could do it without them. I guess that's pretty much the end for the most common types of mineral properties. I'll go over the unique ones very quickly. Unique mineral properties would include magnetism. It's not super unique. It is pretty rare, though, to find sometimes. Galena would react with a magnet. So you can see I have a mineral here. I'm fairly certain this is just slag. But if I were to see, that's a mineral property right there, magnetism. Now, a mineral can experience or exhibit different kinds of magnetism. There's ferromagnetism and a couple others. I can't be bothered to mention that right now. Another unique mineral property would be radioactivity. Very unique, very rare. None of these minerals that I have are radioactive, but these were found at uranium mines, which is interesting. Radioactivity is basically if a mineral displays counts on a Geiger counter, radioactive counts, a certain amount per minute would exhibit radioactivity to a dangerous degree. And the last mineral property, which is unique, but actually not too uncommon, it's unique for minerals, is you know what, I'm gonna have to pull out my notes because I don't know how to pronounce this. Piezoelectricity. That's what it is. I'll put it down there in the video for you. Anyways, piezo, whatever the hell it is. It's basically a mineral exhibits electrical polarization when subject to mechanical stress. So basically, when you break a quartz rock, especially with another piece of quartz, you may see sparks fly, or even just simply rubbing two rough pieces of quartz together. As the small fractures happen, you'll get sparks of electricity. And this is a pretty unique mineral characteristic, and it's pretty cool. Maybe I can put an example of it in the video somehow. It's the magic of editing. There's a lot to learn in a day, and I don't want to stress you out on the geology. So we'll cover different topics in different videos, but for now it was just mineralogy and the mineral properties. I hope you learned something in this video. Hopefully I'll catch you in the next one, and peace.